Sarah, look! We have to do a bio assignment that we need to watch a documentary about and then answer questions.
Oh yeah? What's it about?
It's something called gene therapy. We're supposed to look into its discovery, the political issues, sociology, and all that kind of stuff.
Gene therapy? You mean like therapy for your denim?
No! Genes, like the sequences of DNA that code for what you are and how you look like.
Oh, okay, sounds interesting. Well, let's take a look.
Let's take a look. Every year, millions of people die due to terminal, incurable genetic illnesses such as cancer, cystic fibrosis, and immunodeficiency disorders. Thus, the idea of gene therapy was born. The lack of suitable treatment became a rational basis for extending the scope of genetic technology. The idea first came about in the mind of Joshua Lederberg, before the milestone step of recombinant DNA was taken.
We might anticipate the interchange of chromosomes and segments. The ultimate application of molecular biology would be the direct control of nucleotide sequences in human chromosomes, coupled with the recognition, selection, and integration of the desired genes. It will only be a matter of time before polynucleotide sequences can be grafted by chemical procedures onto a virus DNA. Despite Lederberg's faint hint at the possibility of modifying genes and his occasional work with viruses and their transferable DNA, not until 1982 were experiments actually pursued. With the idea of splicing genes from one DNA strand into another now possible through restriction enzymes, using the same for gene therapy was an idea that was seen by Palmater and Brinster.
Now you see, Ralph? This gene is responsible for the growth hormone in mice. If we were able to add this into the eggs of the mice, we would be genetically modifying the DNA of the future generations.
Let's try it with these mice. The genes in the germ cells are the ones that contribute to the genetic makeup of the offspring, and based on their current genes, they are susceptible to a growth hormone deficiency.
Oh my! These mice previously predisposed for inhibited growth are now able to successfully grow to their normal size. Let's go inform our colleagues.
Germline gene therapy has revolutionary potential. By modifying the defective genes in germ cells such as sperm and eggs, we can prevent these genetic issues from resurfacing in following generations.
Though a momentous part of the history of gene therapy, it is not without its issues. Politics and ethics rise above and hold a strong argument against using this type of gene therapy in humans.
The use of gene therapy is beyond belief. We could cure even the worst of these diseases.
It isn't that easy. People would never agree to this. They see it as immoral. You're meddling with the very thing that makes us human, our DNA, and is going against nature. People like knowing that there's a backup, a way out. Gene therapy at this point is irreversible, and if something goes wrong, we won't be able to fix it. It is our moral obligation to these future generations to keep them safe.
Germline gene therapy is banned for human trials, but another window still remains open: somatic gene therapy. William French Anderson was the first scientist to test somatic gene therapy in humans on a 4-year-old girl with adenosine deaminase deficiency.
So your daughter has a genetic disorder where her blood cells aren't maturing, and her immune system is defenseless against infections. And so your choice to participate in this clinical trial could allow her to live a normal life.
How are you going to treat her?
So I'm going to be using this virus. We are going to inactivate the virus by using a technology called restriction enzymes. This means that we will cut the genes out in the virus that make it harmful when it enters your daughter's body. It won't be able to replicate itself and infect other cells. We will join the normal copy of the gene that your daughter needs into the viral DNA using ligase. We will insert this recombinant DNA into the virus. By removing the white blood cells from her body and inserting the virus will be able to integrate its DNA into her DNA. If successful, this will allow her body to express the right gene that matures her blood cells.
And successful it was. Somatic therapy is more accepted because it only affects one individual and does not raise the same ethical issues as germline gene therapy.
However, the biggest setback in the development of gene therapy that resulted in great political and sociological scrutiny was with the case of Jesse Gelsinger. Jesse had partial deficiency of ornithine transcarbamylase, a disease in which the enzyme that removes excess nitrogen is not properly produced. So what went wrong? Why did he die?
Well, viruses are unpredictable. Although the viral vector used for Jesse was the same as all other trial participants, his immune system reacted badly to it and started attacking his body. Not only that, but these reports show that the virus traveled to other parts of his body and accumulated in his spleen, lymph nodes, and bone marrow. In the end, he faced severe blood clotting and multiple organ failures.
Investigations into Jesse's death led to criticism of the competence of gene therapy.
Look at what I found at the research center. These files show that people actually died using the same viral vector as Jesse, yet he was not informed of this. Nor did I find official consent to Jesse's participation, and clearly the staff were not properly trained to handle this trial to begin with.
I can't believe this. We need to put these trials on hold. We can't risk any more lives. The technology is just so new. The government doesn't even know what it's supposed to be regulating, and blindly funding gene therapy isn't going to cut it anymore. The public doesn't trust that it works, and putting money and resources into it might not be worth the consequences.
Even with this setback, gene therapy technology has slowly been developed to what it is today. There are still so many unknown parts that need to be discovered, but with more research, gene therapy may soon become a possible procedure for disease treatment.
Wow, that was interesting.
Hey, do you think I can modify my genes to fit into these genes?
I don't think that's what it's meant for. People are probably concerned about just that if gene therapy was to become widely used, it would be widely abused too.
Well, I'm willing to pay for it, so why not? By the way, how much do you think it's going to cost?
Let me Google it. Whoa! Your broke self won't be able to afford it. Don't you worry, unless you can scrounge up $1 million.
Holy cow, so expensive! How is that even going to help the economy if only the rich can afford it?
Well, if you think about it, it will completely change the medical field. It'll open up so many jobs and essentially an entirely new industry. When scientists find out enough to use it commercially, it'll become quite literally uncontrollable.
Only time will tell. Until then, let's work on this assignment. So, we're supposed to create a video outlining the historical, political, and sociological backgrounds of gene therapy, I hear?
Yeah.